Once again, good morning, grade 8 physics students. Today we are going to continue our lesson number 2 that is entitled Power. For Chat with the Expert, the power is the rate of doing work. It is work per unit of time. It determines the length of time it takes for work to be finished or done. In scientific language, power is the ability to finish work within the shortest possible time. So when we are going to measure power, okay, here is the formula. Power is equivalent to work done over time, or in abbreviation we have P is equal to W over T. All right, so power is directly proportional to work. Here is our our explanation. In symbol, we have power is directly proportional to work. If power increases, work increases. If power decreases, work decreases. All right, that's the meaning of its relationship. So this means that the more work done within a constant time, the more power output is, and the less the work done, the less the power output is. On the other hand, power is inversely proportional to time. As we can see in our symbol, power is inversely proportional to time. That means if power decreases, time increases, or if time increases, power decreases. If power increases, time decreases, or if time decreases, power increases. Okay, so as an explanation, this means that the longer the time used to finish work, the smaller the power output is for the same work. Also, the shorter the time needed to finish work, the greater the power output is for the same work. All right. So, when you go upstairs fast, you expend more power in a shorter time than when you go slowly. So power is measured in joules per second. So J over S, or watts. So these are the units of measurement for power. Watt, or in symbol W, is derived from James Watt, his famous Scottish engineer who invented the first modern condensing steam engine. Aside from this, other related units are used. So here are the units that are being used. 1 joule per second is equal to 1 watt. 1000 watt is equal to 1 kilowatt. 1 horsepower, or HP, is equivalent to 746 watts, and 1 kilowatt is equivalent to 1.34 horsepower. Although we know that the HP, or horsepower, is not an SI unit, it is often used in measuring the power engine. Yes, we can see the horsepower units being used in our electricity supply and its like. The unit watt and kilowatt are usually seen in, of course, yes, in electrical appliances, in electrical energy consumption data, and the power ratings of television set, electric fan, rice cooker, refrigerator, and other appliances may vary and are measured in watts. The usual power ratings for certain appliances are as follows. If you have a television set, it has 100 watt. Electric fan, it has about 80 watts. Rice cooker, it has 750 watts. And refrigerator, it has 120 watts. So out from this, you will be able to compute our electric bill using this watts and its how many amount per a certain number of watts that is being used. So example number 1. Let's copy this one. Okay, and then let's solve it in the other side. Okay, so copy. So we have here one example of word problem for the lesson number 2, power. So example number 1. Let's make it a little bigger. Okay, this is our word problem. Okay, So two students are asked to transfer the teacher's table to a corner at a distance of 5 m. So let's make a table. If this is the table, okay, we are going to transfer the table to other side. There are two students here, one and the other one student. Okay, so they are going to transfer it to the other side with 5 meters. If their combined forces, so let's their combined forces, all right, is equivalent to 100 Newton, and they finish the job in a certain time, which is equivalent to 10 seconds. What is the power output in watts and kilowatts? All right, so we all know that our formula is what is equivalent to, can you still remember what's our formula? We have power, right? What's the power output? So the unknown is P, is equivalent to work over time, right? So since the given is force, okay, let's enumerate the given. Force is 100 Newton and time is 10 seconds, and distance is equivalent to 5 meters. So what we are going to do is to know what is the formula for work. Remember that the formula for work is F, or force times distance. So we have force times distance over time. So this is the formula for work. So let us substitute 100 Newton times the distance 5 meters over our time 10 seconds. So we are going to multiply 500 times 100 is equivalent to 500 Newton m over 10 seconds. Okay, so we know that Nm is equivalent to joules. So 500 divided by 10 is equivalent to 50 joules per second. This is our power. All right, so this serves as our answer. Okay, let's try to go back. Is it correct? Yes, it's correct. And also, of course, as we all know, 1 joule per second is equivalent to what? So we can also have 50 watts. All right. So this is the answer in watts. And we all know that 1 kilowatt is equivalent to 1,000 watts. So if we'll convert this to kilowatt, so we have 1,000 watts is equivalent to 1 kilowatt. Therefore, we are going to cancel, and then move how many zeros? 1, 2, and then we will have 0.123. Okay, so we will have 1,001, 2, 3. We will have 0.05. That's kilowatt. Okay, let's try to see if we have the same answer. Let's go back to our module and let's try to see. Okay, yes, that's true.